Hey, third grade. All right, we are going to be continuing working with geometry. Okay, this is the last week that we're going to be doing geometry. So let me go ahead and I'm going to show you a couple things today. This first thing that I'm going to show you is how to get to this website that has virtual manipulatives, okay? So if you go to your Google Classroom and you go to the Today tab, there is going to be a material that's going to be posted called Virtual Manipulatives. If you click it and click the link, it's going to take you to a brand new website, all right? So it's going to take you to a new website, and what I want you to be clicking on in this website is the Geoboard, okay? You guys can open the web app or you can download it to your Chrome app. But for now, I'm just going to open the web app. But I do want to show you that there are several different things that you guys can use for virtual manipulatives. So there's a Geoboard, okay? And we're going to be using this one today. There's also number frames. There are number pieces. So these are your base 10 blocks, which some of you really like to use. And I encourage you to use these base 10 blocks. Pattern shapes, fractions, money pieces. And let me show you. There's some vocabulary cards that you can use to help understand key terms in math. There's a whiteboard app. If you click on this, you can draw on it. There's a number rack, which you can use for counting. There's number lines, which are really, really good. And then there's a clock when we get into working on telling time. So I really want you guys to be utilizing this website. It's really awesome. It's really beneficial. Mrs. Ritter, our math specialist, showed it to me and wanted me to share it with you guys. And I think it's awesome. We've been using it. I've been playing around with it so I can just kind of learn it. But you guys are going to be using this website today to show me some of your work. Okay, so it's really, really important that you guys just play around with it, mess with it. Let me know if you have any questions about how it works and what you can use the different manipulatives for. Okay, so let me go ahead and open up. I want to use Geoboard. And I'm going to open web app, okay? Down here, you can change the shape of your Geoboard. I want the long one. And let me extend my... Okay, so now I can use these little rubber bands. I know that you guys have probably used this. If you drag it, and then you can drop it, and you can make different shapes with your Geoboard. All right, really fun to use, and I'm going to give you instructions on how to screenshot it so you can send me pictures of what you're working on. All right, so and then if you want to erase something, you can just click this little start over button, clear all, and it does that. If you want to erase just one thing, like if you just want to get rid of one rubber band, you just click the rubber band, and then down here is a little trash, and it takes just that rubber band away. And let me show you, like if we have multiples. So if I want to just take away, I don't want this green one, I just click the green one, do the trash, and it takes just that green one away. All right. So let me go to this. All right. So today we're going to be finding, congruent figures or congruent parts in a shape that is the same size, two congruent shapes. We're going to be finding congruent parts even though they don't look alike. All right, so we're going to be dealing with some fractions today. So what I'm going to show you is on my Geoboard is what I'm going to show you first, okay? All right, let me make I'm going to do a 1, 2, 3, 4 by 4 square. 1, 2, 3, 4, 1, 2, 3, 4. So I'm going to make 2 4 by 4 squares, okay? And actually, let me make this in a different color. Let's do red. Just showing you how to do this. 1, 2, 3, 4. You're just dragging and dropping. Now, it's really important that when you're making your shapes, you have congruent figures, okay? Because if they're not congruent, then you're not going to be finding pieces or the area of pieces that are the same. Your figures have to be congruent. So I can break this up, this square, lots of different ways. But what I'm going to do is I'm going to do that. I'm going to make 4 boxes, okay? And on this one, I'm going to do 4 rectangles. So I'm going to break it up going vertical, okay? Now, down here you also have like a little marker and a pen that you can use. This piece, oops. This piece right here, oh, Miss Garza needs the marker. This piece right here, and I'm not going to shade in the whole thing because it got a little crazy. This piece right here, okay, that is 1/4 of my square, okay? But this is also 1/4 of my square. Now, they look different, okay? The way that these figures look, or the way that the 1/4 looks, is not the same in both pieces. I'm trying to get this a little bit nicer. Okay, this is 1/4 and this is 1/4. Now, those pieces don't look the same. But they have the same, like they are the same size. They just look different, okay? They are both equivalent to 1/4 of your square because your square is equivalent. Both of these squares are the same size. And then 2, you have each square cut up into 4 pieces, okay? So let me do another one. One, 2, 3, 4, 5, 6. I'll do 6 by 4. 1, 2, 3, 4. All right, and I am making a rectangle. Okay, and I'm going to break this one up into, I'm going to do 2 pieces. I'm going to do halves, and then I'm going to do the same over here, and it's just going to look a little bit different. 1, 2, 3, 4. Okay, and I'm going to break this one up into halves as well. All right, so I have 2 rectangles that are dimensions 6 and 4, 6 by 4 rectangles, okay? I have them both broken up, so both of my rectangles are equivalent. That is the first step that you have to make sure, okay? Both of them are equivalent. Now, the second step is, do they both have the same number of pieces? Yes, they do. 1, 2, 1, 2. They both have the same number of pieces. Something I didn't say in the last one was, are each piece on each shape, are they equivalent? These 2 are the same size, and these 2 are the same size. Now, if I had done something like this, now, do I have 2 pieces? Yes, I have 2 pieces in this square, but these pieces are not equivalent, so that is not going to be a equivalent fraction or equivalent part of the piece. All right, so they have to be the same size. So here we go again. This right here, oops, this side is 1/2. This side is 1/2. All right. Now you guys are going to make a couple of these and you're going to take a screenshot of them and upload them to your Google slide. And I'm going to give you directions on how to do that. But what I want to do is I want to go over some questions. All right. So these are the type of questions that you're going to see when you're being tested over this specific skill. So these are what the questions are going to look like. Okay. So this says 4 congruent rectangles are divided into 3 parts as shown below. Each one of these rectangles is the same size. Okay, that is the first step. Are all of your rectangles the same size? Yes, they are. Divided into 3 parts below. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. That is a true statement. Now, which one of these, the area of part 1 is equivalent to the area of which other parts? Well, this second one right here, those are not all the same size. Each piece, each part is not the same size. That is not going to be your answer. These 3 are not all the same size. That is not going to be your answer. The area for part 1 is equivalent to the area of which other part or parts? Only 4. Right here, this is 1/3. And this is 1/3. This piece right here is not 1/3 because this rectangle is not divided or broken up into the same size pieces. Same thing here. This is not 1/3 because each of the thirds or each of the parts is not the same size. They are not equivalent. So part 1 is equivalent to the area of which other part or parts? Only 4. All right. Let's do one more. Bertha shaded 1/4 of a rectangle. The shaded part of which rectangle has an area that is equal to the shaded part of Bertha's rectangle? Well, first of all, let's make sure that the rectangles are going to be the same size, okay? Those are all going to be the same size. That's the first step. You need to make sure that your shapes it's the same shape and they're equivalent shapes, okay? That is a true statement. Are they all broken up into 4 pieces? 1, 2, 3, 4. 1, 2, 3, 4, 5. That cannot be your answer. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so now I only have 3 rectangles left. And the last step is to make sure that your rectangles are broken, or your pieces are broken up into equivalent size pieces. These are not equivalent. All right? And these are not equivalent. You have a piece right here, but then you have this bigger piece over there. Same thing here. You have this small little rectangle and then what looks like an L. Those are not equivalent. So letter G, this is 1/4 and this is 1/4. Okay? So that is what you guys are going to be doing. You guys have one more question that I would like you to answer. Omar drew 4 congruent rectangles, then divided them into parts. He labeled 4 of the parts J, K, L, and M. Which 2 parts have equal areas? So 2 of these pieces or 2 of these parts are going to be equal in area. And then you'll just type your answer. I'll give you an answer box and you'll just type your answer. Okay? All right. If you guys have any questions, please let us know. And if you need any help, you need to be hopping on to office hours. I'm going to make sure that you have instructions on how to attach a screenshot of your Geoboard and you creating shapes that have congruent areas.